Okay, so if you can see this, this is the assignment, right? So if you can see here, the slope of the blue line, which is represent the bank, and the slope of the red line, which represent the stocks, will surely hit at certain point. So in this case, 6 years. If they are parallel, so then you can stop anywhere. But when they have different slope, they should meet somewhere.
Okay. Okay, thank you, sir.
Excuse me.
So if the slope is meeting at negative, so you don't need to extend also. So in this case, you know that the slope is meeting at a positive year.
Excuse me, I'm a bit
Yes.
confused. So
Which one?
when I thought the way you got expected value is that you multiply it into the probabilities.
Correct.
The gain,
Correct.
right? But if
Correct.
you multiply 100,000 to -1 and 0.1, you get -10,000, and it gets rid of it makes the expected value of stock negative, I think. So like,
Yeah, why
is it-
not? Expected
why-
value can be negative, you know.
so why would it increase then for until 1
Most
to 6?
important here is the sum of probability. You see this? Must be 1.
Yes.
Okay. So the value here is up to you. The one in yellow is up to you. This is depend on your problems. So in this problem that I give you as assignment, we put here that you see, you will lose your money at probability of 10%. That means the result is -1, right?
Yeah.
Meaning -100. -1 means 100%. You will lose your money. This one is the probability of the probability. You see that the gain is 7%, correct?
Yep.
Okay. This one, the gain is 5%. The gain is 3%. This is the gain of 10%. Is that correct? Wait.
10%.
Yes, but how do you get from minus 100,000 and you put 85,600, then it becomes 93,028, and then increase again. Oh no. Yeah, the column that you have for the -1 and 0.1, sir.
It should. I think 0.1 should be 0.01. It's 1%.
Yeah, okay. 0.01. Sorry.
Oh.
Okay. Now, in this case, you will meet at not 6 year, at 9 year. At 9 year, then it is correct.
But I'm confused why stocks expected value is increasing when the negative is so high. So like
negative is only 1%.
But the fact that you lose 100K, doesn't it mean the expected value is negative, always negative?
No, the expected value is this one. This is the expected value. Can you see it? The sum product of all. Right here, in this case, you get the gain, okay, of 7%. This F25 here is 7%, multiplied by F29, which is the year 0.
So that is if you gain 0.07.
Correct. Correct. That is 7%, right? And then in the second year, okay, this is your additional interest, isn't it?
Yes.
You know the formula of interest? I will show you in the screen. Open the screen here. Maybe I need to stop this. Oh, whiteboard here. So the formula of interest is P, okay, oh sorry, F equal to P plus K times P. Correct or not?
Yeah.
So this one is the interest. Okay, this is the interest. Meaning if you have your principal plus the interest is the future value in 1 year. Okay, so then you have second year, this is F1, right? So if you have F2, what is that? F2 is equal to F1 plus K times F1. Correct or not?
Yeah.
Okay, then if you want to go back, usually what you have is based not F1 but based on the principal, right? Year 0, right? In that case, you will have P 1 plus K plus K times P 1 plus K, right? In this case, equal to P 1 plus K exponent 2. Is that correct? Any question here?
I'm sorry, sir. I ran into connection problem.
Oh, okay.
I want to ask more about that table though.
Which
that
one?
Excel.
Excel. Okay.
Yeah.
Let me put back to Excel. Which one? Can you see it?
I can't see it.
You cannot?
No.
Okay, let me stop sharing and put back to the Excel. Okay, which one?
So on the right, on this is basically in one column if it keeps going that way, right? So 0.7, 0.7, 0.7. If you keep gaining that much.
Correct, correct.
But on the
one column.
furthest right column, it means if you lose all your money, why do you still get? Why do you get 80?
This
from
one
minus 100.
Wait,
to
this one is all
84.
negative, right? You see this?
Yes,
Column
it's
J,
all negative.
all negative, correct?
Yeah.
Okay, so column J is all negative. But don't forget, this is only 10%. So that's why we put in here the sum product of this value multiplied by the probability. Can you see? Do you understand sum product? That means 100,000 times 50%, 100,000 times 1%, 10%, right? This is another 100,000 times 20%, and so on. So I will put the percentage here so that you can see. Can you see it? So now, if you see this, for example, where is your problem here? Year 1, year 2?
84,000 minus
Okay, year 1.
84,000.
Okay,
Yeah.
year 1 here is you have 50% to get the 7% return, right?
Yeah.
So if you look at this value, okay, this value is 107 multiplied by this 50%, okay, plus, okay, this one, 105 multiplied by this 10% here, plus, okay, this one, 103 multiplied by the 20% here, plus this value multiplied by this value, the probability of 10%, plus again, okay, negative value, right? Multiplied by only 10%. There, I get 84,700. Of course, this is the formula of some product.
Oh, so to find out the value in the J31, you cannot just do like the -1, because I thought it would be minus 90,000. So you use some product to find it.
No. You need to multiply by its value multiplied by the probability, and then you sum. Remember, the risk is probability times value. Expected value, EV, is the probability multiplied by the value, and then you sum all for all values. So this is expected value. Expected value is the sum product of probability times value. The one in green here is the values, okay? And you have the probability. Okay, these are the probability. So then you multiply probability with the values, you get expected value. Do you remember? In the slide of decision under risk, let me share you the decision under risk. You remember, here it is. Okay, so expected value is the probability times the value. And you practice that, remember that. You have probability times the value, right? So the only difference is in this practice, now you have probability times the value for each year. So that the decision is for each year in this case. Can you see that or not? Right. So in this case, you have the decision for each year.
So 10% you lose all your money, right? So should it be 0, not minus 100,000?
Minus 100,000 for the first year. You see here, minus 100,000. At certain year, for example, in the 5th year, you have a minus 101,000.
Oh, it doesn't become 0. Huh?
In the 9th year, you have minus 125,000. But again, that probability of minus 125,000 is 10%. While you have 50% of earning 183.
Okay.
Make sense?
I think so.
Okay, so that's the nature of probability, right? So even if you lose, but that losing is only certain amount of percentage. So what do you think? Is there any question more? So try to do your assignment, okay? If you submit it, you on time, you get 100. Even if you are wrong, no problem. It's just compliance, you know. But the answer, I will update in the slide. Okay.
Okay.
Okay. So any question about decision under risk and value of information? If not, we can continue with the new topic about utility and group decision making today. Is there any question? By making the assignment, you will have doubt, right? You start to think because now you see the real problem that you're facing. Okay. So, okay then, let's continue with our topic today, which is utility theory. So actually, what I give you here is more practical than theory. In fact, I did not touch any utility theory in this slide, right? Anyway, so we have discussed decision under uncertainties, under certainty, under risk, okay? So today we will discuss about decision under utility and group decision making. So if we finish, we can continue with game theory. Otherwise, we will continue game theory next meeting. Okay. So let's discuss this. Suppose you have two choices. Okay. Option A is guarantee payoff of 60,000. Option B is 50% chance you gain 150,000 and 50% chance you lost negative 30,000. So which one you will prefer, A or B? If you calculate the expected value, they are exactly the same. Okay, 150 times 50% minus $30,000 multiplied by 50%, you will get exactly 60,000. Okay, tell me, which one you will choose, A or B? Okay, let's see. Darin, what do you think? Are you still there, Darin?
Yes, sir.
Yeah.
I will choose A
Why?
because I still get the money and there is no risk that I will lose my
Okay,
money.
no risk. Okay. How about you, Eugene?
Yeah.
Which one you choose, A or B?
I think I will choose B
You will choose B. Why?
because despite the loss is 30,000, the money that I will probably gain is 150. It's like 5 times of the loss. So I think I will choose option.
Okay. How about you, Abel? Which one you choose?
Isn't the expected value of B higher? Because half of 150 is 75 and half of 3K is 15.
Negative 30.
Oh, negative 30.
Loss.
Right. Yeah. I think I would still pick option A though.
You
I
will
still-
lose $30,000.
I don't like losing money.
Okay, you don't like losing money. Okay,
Yeah.
then you push A. Okay. Stephen.
Yeah, I agree with Eugene, sir. It's I got the risk reward ratio is 1:5, so I will take B
B.
because of the risk reward
Okay.
ratio. Yeah.
Lilian.
I think I would go with A.
A. Okay. Nyoto.
I'm not a risk taker, so
Okay.
I'll go with A.
Okay. We have a visitor here. Michelle, what do you think? A or B?
I think B.
You are B. Okay. Okay. Both of you are correct. Okay. A or B, it doesn't matter. That represent you. Okay. So there is perception difference between A and B, right? So the X is 60,000 success minus 30,000 failure, okay? And Y is 60,000 success minus 150,000 success. So if you feel X is greater than Y, then you will select option A, okay? So in this lesson, you will learn how you will quantify your feeling. Okay, so now let's change the two Campbell problem earlier with this new one. So I will call this Campbell A and Campbell B. In Campbell A, you will win 100,000 with probability 1%, or you win nothing with probability 99%. In Campbell B, you will win 2,000 with probability 50%, or you will win nothing with probability 50%. Now, which Campbell you prefer among the two? Let me record a while ago your answer. Huh? In sorting versus Campbell, who choose Campbell? Campbell is B. I remember Eugene choose option B, right? Who else choose option B a while ago?
Stephen and Michelle.
Okay, Stephen and Michelle. Okay. Now you have a Campbell versus Campbell. Okay. This is in this problem, two Campbell problem. The first problem was sorting versus Campbell. Some of you will select sorting, right? Mostly. Now in Campbell versus Campbell, now question, which of you will select A? Anyone?
I'll choose B, sir.
Nyoto will select B. Okay.
Same. I'll just be the.
Okay, I'm asking who will select A among you?
Yeah, I'll select A. Why not?
Who?
Me.
Abel?
Abel. Yeah.
Abel will select A.
Darin.
Who else will select A?
Darren, sir.
Darin, sir.
Darin will select A. But this is inconsistent, huh? I was expecting the one who select A, either Eugene, Stephen, or Michelle. Right? No?
No.
No?
The probability I will win nothing is 0.99. While the probability I win that lot of money, 100,000, only 0.01.
So why did you take the option B before then, Eugene? Isn't it the
Because
same?
the probability is, I think the probability before is still like logical, like 50-50. But this one you can see 99% and 1%. No,
Okay.
I will not choose Campbell A.
Okay,
Okay, you will not choose B. Okay. So who choose A is Abel and Darin in these two Campbell.
Yep.
Okay. So if you draw decision tree of two Campbell's problem, what is the EV? Anyone?
Aren't they the same?
Yes, the EV is the same, right? So the EV is exactly the same, right? So the EV of two Campbell problem is exactly 1,000. So, but even in here, okay, if you use the decision under risk, you cannot decide, isn't it? because the EV are exactly the same. But anyway, you still decide, isn't it? You still decide A or B. So why you decide A, why you decide B? That is because of certain utility. Can you get it? What is utility? Utility is something that inside your mind that you cannot express it, but actually there. Okay. So if you like gamble 1, okay, gamble A, okay, so the EV is 1,000, but the price is actually higher than gamble B, right? So if you like gamble A, you are actually risk lover. If you like gamble B, okay, you are risk averse. So Abel and Darin are risk lover, right? Between Shore and Gamble, Eugene, Stephen, and Michelle are risk lover. So the attitude between shorting and gambles and gambles are different. So in here, we have 3 attitudes of risk, okay? So you as the decision maker can be categorized into 3. One is called risk averse, the second is risk neutral, and the third one is risk taker. So what is risk averse? Risk averse decision maker will prefer sure things to gamble. Okay? If all alternatives are gambles between 2 gambles with equal EV, you will prefer safer gamble. Okay? Now, if one gamble have higher EV than the other, then you will select gamble with lower EV if it appears risky. Now, risk neutral is indifferent between shorting and gamble. If all alternatives are gambles with equal EV, again, you are indifferent. You cannot decide between the gambles. Okay? Now, if one gamble have higher EV than the other, then you will select gamble with higher EV. Similarly, risk taker will prefer gamble over a sure thing, right? If all alternatives are gamble, so you have no choice, right? Then you will select gamble with higher EV. If all alternatives are gamble with equal EV, then you will prefer riskier gamble. So now you can decide on your own which type of decision maker are you? Are you risk taker, risk averse, or risk neutral? Right? So utility theory is an approach to assess the risk attitude quantitatively. So you want to quantify, okay, the feeling of decision maker using numbers, okay, using preference. So what is utility? Utility is defined as a measure of total worth, okay, of a particular outcome. So here is example how you will create utility. Okay, so if the payoff is, what is the maximum and the minimum? Okay, so for example, the maximum payoff is 2,000, the minimum is negative 500. Okay, so the maximum payoff 2,000, you will put utility 1. The minimum payoff of negative 500, you will put as utility 0. Okay, then you feel the value in between. You can feel subjectively, okay, the value of utility in between. For example, I put, if 1,000, I will put 95%. If 500, I will put 80% and so on. Okay. And then you can throw. You can throw. Okay. So when you throw between the value on the x-axis and the utility in the y-axis, then you can check whether you are risk averse or risk taker or risk neutral. Okay. Now, for your practice right now, let's say, say you want to have certain gamble. Okay. You want to take a certain decision. Now, put what is the maximum and the minimum payoff, and then can you fill up the utility value? And then can you draw it? Say, let's to make it equal, huh? So let's do this. Say the maximum is $2,000. Okay. The minimum is -500, similar to this one. So now question to you, can you fill up the value on your own? And then you share your screen. Can you?
So the utility value is up to us or?
Up to you, it's subjective.
Oh, we can just use the same value like 2000, like what you said,
It's
right?
up to you. If that is your preference, then it's okay. Anyone? Oh, I give you chance for sharing your screen, one or two of you. Can you practice to make your own utility? Your own personal utility. So this is my example. Can you see it? Anyone want to share your screen?
Yes, I would like to
Okay.
share my screen.
So can you share?
Yes. Wait, I'm still typing. Should I share?
Sure.
So, I'm using the same value as the 0 minus 100. This one. So,
then at the bottom, okay, minus 500, you put 0, and 2,000 is the maximum, so you put 1. Anything in between is up to you.
so this one is 1.
Yes, under 2000 you put 1. That's the only things that is required, meaning that you want to put probability or utility is between 0 and 1. Huh? Similar to probability. So this is basically cumulative probability, something like that. But as if this is cumulative probability, but it is not. So it's representing the your preference over certain things. So you fill up and then you draw. You know how to draw in Excel?
Using the
Chart.
insert chart. Okay, wait.
Oh, you fill up the value first.
So the value between 0 to 1. Yeah?
Correct. Of course, you know, if 2000 you feel this is 100% you like it, right? If 1000 should be lower than 1, right?
Yeah.
Only 500, that means you again should be lower than if you get 1000, right?
I think so. Yeah.
So how much lower is up to you, but the order matter here. That's the meaning of utility. Utility is basically about ordering.
So it's like priority.
Yes, correct. So how
Yes.
is the order is the value itself, it doesn't matter, but the order matter. Okay. Say you can put 0.2, 0.1. It's up to you.
And so and for 0, I cannot put 0.
Yo, if you put 0, then negative is also 0. That's fine. Why not?
Yeah. So I'll do this.
Okay, then you draw.
Where's the chart? Line chart or
Line chart. Or XY. XY. XY chart.
XY chart? Which one?
The scatter chart.
Oh, wait.
Yeah, that one. Down.
This one?
Below. Yeah, that one. With the line.
Oh, wait. Oh.
I think you're in. You just need to add.
With the line.
Okay, that one, correct. Very good. So, what type of, okay, now you can see Nyoto's utility, okay, personal utility chart. Okay, so let's come back to the, I will stop your screen, okay, Nyoto?
Yes, sir. Okay.
Okay. So, there are several utility functions. This is like theoretical utility function that you can also use. Okay. If first is polynomial, second is exponential, then there are many other functions that you can use, but these are the most used utility function. If you are risk averse and you use polynomial, then you can use square root. If you are risk taker and you use polynomial, then you can use square, yeah? Quadratic. If you use exponential, this is the most often used. I put yellow here. Okay. If you are risk averse, you will use 1 minus exponent of x divided by certain r. R is a constant. Yeah? And if you are risk taker, So you use that function, exponent of x per r minus 1. Okay, so now if you use polynomial, you will get this kind of curve. You see, a while ago, Newton's curve is look like the purple one here, correct?
Yes, sir.
Meaning that Newton is actually risk averse.
Yes. Correct.
Correct. Okay. See, by charting your utility preference, you can already see what type of risk taking are you. Okay. So the advantage of a polynomial utility function is you can normalize to the scale of 0 to 1, and you don't need any parameter here. Okay. So, but the disadvantage is it is only for gain payoff, so x cannot be negative. But of course, if you really need to have a negative, then you need to scale up by taking the absolute value. Now, how do I know, okay, from the chart alone, how do I know if I'm risk taker or risk averse? So that based on the chart of utility theory, and you get actually the second derivative. Yeah? If the second derivative is negative, so you are risk averse. If the second derivative is positive, then you are risk taker. Yeah? And if your second derivative is 0, then you are risk neutral. Until here is clear, right? Next. So this is like personal attitude toward risk, the one that you just practiced a while ago. And then when you chart it, okay, then you see the value here. So in this example, okay, you can see whether it's concave or convex, right? So in this example, I can show you that when the payoff is positive, okay, this person become risk averse, but when the payoff is negative, suddenly the behavior change, become risk taker, if it is cost. From the curve, you can see whether it's concave or convex, right? Now, if you don't know, okay, if you want to use the theory of utility function and you don't know what is the utility function, this is the most used utility function, which is exponential. So the utility function is 1 minus exponent of minus x divided by r. What is r? R here is called risk tolerance. This is representing the shape parameter. Okay, so by changing the r, you can actually change between risk neutral until very risk averse. So the graph here, you can see when the r is very small, 0.5 up to 4, right? So when the r is big, like 4 here, it becomes risk neutral. When the r is actually small, it becomes risk averse. Okay. So this is the one that you will use later on when we play with utility function. So what is risk tolerance? It's basically a shape parameter in utility function of exponential. Okay, assuming you are actually risk averse. My question to you, why the one that we use is actually utility function of risk averse, not risk taker? Anyone can answer that? Why we use utility function of risk averse to risk neutral rather than risk taker? Remember, this function in the table here is actually the one in here. You see, this is actually risk averse, right? When you use risk taker, you're supposed to have exponent of x minus r negative 1. Why we did not use risk taker? The answer is because most people are actually risk averse. Risk takers are very rare. Okay. Now, the question now here is, how do I calculate the risk tolerance? Okay. If you want to get the risk tolerance, think about it as having a lottery. Okay. The win payoff is 8 with probability 0.5. The lose payoff is L with probability 0.5. Now, you have a payoff of C when you are indifferent between playing lottery or getting C with certainty. Okay. Now, given the utility function, then you can put this value, okay, this formula here. Let me throw with the red. This formula here, you put it into this utility function, okay, you will get this equation, right? Now using this equation, now you can find the risk tolerance. In Excel, you can use Colsic. Okay, please record the formula here. And then can you calculate the risk tolerance given the win payoff and the lose payoff and the indifferent payoff? So I want you to practice something like this. So in Excel, okay, I want you to practice to get the risk tolerance. Can you do it? First, you put A. So this chart is.
So we use that data, which data, sir?
No, you create the data, something like this. Can you see it?
Uh-huh.
Okay. So you type H, L, and C, and then you put value. So H is equal 1, L is equal 0, or any value here, and C is up to you. So the one in yellow is something that you fill in. Okay. The left-hand side, how do you get the left-hand side? Is this formula. Let me share the formula. Here. Can you see the formula here?
Yes, sir.
This is the one that you will, wait, hold on. So this is the formula that you will use. So the left-hand side is exponent of minus h over r. The right hand plus exponent of minus L over R. The right-hand side is 2 exponent of minus C over R. Okay? So then you will get, so here, can you see the formula? Okay, exponent of h over R. And in the right-hand side, you will have 2 multiply exponent of minus C over R. Okay? Then you calculate the difference between left-hand side and right hand side. Okay, so then you can use here what if analysis and you do goal seek. Okay, so you want to set the cell of the difference to 0 by changing what? You will change the R. Okay, by changing the R. Okay. See here, for example, I will put this R is first time I put any number here. Okay. This is also yellow so that you will see. So this is the difference, right? If I put 1, R is 1, I will get this difference. So I use theta, what if, goal seek. Now I make the difference into 0 by changing the R. Okay, so I got R is equal to 970. Can you see that? So back here. So if your C is 0.5, you will get R is about 18.79. Yeah? 18 basically. Depending on the value of H, L, and C, you will get different R. Anyone want to share screen? Karin, you want to share your screen?
No, sir.
Why?
I haven't do it.
Oh, that's sad. You need to practice. Lillian, do you want to share your screen?
Okay, wait. I still make the data.
Okay. Anyone?
I can share it, but I'm
Okay,
not
okay,
on the right
sure.
side. So this is left hand side. So
Okay, then you calculate the right hand side. Two multiply by 2 multiply. Okay. 2 multiply by exponent minus C over R. C over R by R. Okay. Then you take the difference. The next one, next column or next cell, minus. Okay. And then you go to theta. What if? Goal seek. Okay.
so we want to set this value to 0.
To 0. The R you can set the R you can set 1 first at the beginning so that you can see how it changes.
So we're changing the R sign, right?
Yes, you want to because at this point you don't know what is R, right?
Okay.
Okay, so when you get that, when you click OK, you get 18 point something, right?
Yep.
Yes, good. So I hope you can practice this. This is super simple. So this is how you get the value of R, the risk tolerance in utility function, okay? Now, Now, in this practice 3, now I will share my screen again. In this practice, you will compute the utility of expected value, okay, of the two Gumbel's problem earlier using polynomial utility function for risk taker, for risk neutral, and risk averse. Okay. The one that I give you here are the probability and the payoff of the two Gumbel's problem, Gumbel A, Gumbel B. So I want you to practice, okay, to compute the utility of the expected value. Okay. So in this case, if you are using risk averse, okay, because you are using polynomial, then you will get the square root. If you are risk neutral, the utility is exactly the same as the EV. Okay. Now, if you are risk taker, the utility is the EV square. Okay. So in this case, okay, if you are using utility of expected value, again, you cannot decide because their EV are the same. Okay. So simply by putting the utility of the expected value, you still cannot decide if their EV are the same. Then how do I decide based on utility? To make decision based on utility, you need to compute what is called expected utility. So what is expected utility? Expected utility is the sum product of probability with its utility. So let's assume that it is utility of a gain, right? Then the sum, the average utility in this case, okay, the weighted average of utility is the one that you use to make decision. In this case, of course, your decision is based on argmax because it is based on the gain. So can you again compute, okay, the expected utility of two Gumbel's problem based on EU, expected utility? Again, you assume that it is polynomial utility function. So in this case, you will compute something like this. Okay, I want you to practice this and then tell me if you understand or not.
I think so.
Can you try? So, do you know why the formula is something like this? Why this is square root and why this is a square?
Which one is square root, sir?
The risk averse is square root.
Oh, yeah.
Do you know why?
Because the
Because do you know why we use
Because you want to minimize. I don't know.
No, no, not because we want to minimize. Because we are using this table. I will show. This one.
Oh, using the polynomial thing.
Correct. Because we are using the polynomial. Okay.
Okay.
So if we use polynomial, risk first will be square root
Square root of.
will be square.
Yeah.
Okay. And utility of risk neutral will be exactly ux equal x.
When do you decide whether using polynomial or exponential, sir?
It is given if it is in the exam, but if it is not in the exam, using in practical way, you
Yes.
decide on your own. Okay.
Mm.
You can decide on your own whether it is polynomial or exponential.
Okay.
Okay, so this is the drawing of polynomial, and this is the drawing of exponential, you see? So basically the drawing is the same, right? The difference is in exponential, you have shape parameter, which is the race tolerant that you just practiced a while ago. In polynomial, you don't need to have any parameter. Can you see it? So in here, you don't have parameter, right? Utility is based on x. In exponential, your utility is based on x and a parameter r.
Oh, I see. Okay.
Can you see that? So the parameter r is the one you just practiced a while ago, the risk tolerance. Then you ask, how do I get the parameter r? The one that you just practiced a while ago. You get the parameter r by setting the high value, low value, and certainty. C in here represent the certainty. Right? So if you know the win payoff and the lose payoff, okay, and certainty, C, then you can actually calculate the risk tolerance. Can you get it or not? So once you get that, you can calculate for each decision type, okay? Risk taker, risk neutral, and risk averse. Okay. Again, if you use exponential utility function, say with risk with shape factor, risk tolerance equal to 5, then you can also calculate for, in this case, between shorting and gamble. Can you practice to calculate? So this one is the one that you use. For example, you use exponential utility function, then you will get this value. Of course, one is positive, 0.999, the other one is negative 200, then you will select option A. My question to you is, why I use this formula here? Do you know why?
Which one, sir?
Here in answer of practice 5.
Because you just exponential.
Correct. Okay, because we use the exponential. So, because the problem here is if you use the exponential function, right, instead of polynomials. So the function is given that you can calculate. Okay. In reality, that depends on you. Whether you want to have an exponential function or polynomial.
So I'm sorry.
Yes,
For
please.
question practice 5, we can also use the polynomial.
Yes, you
Oh,
polynomial, but if you use polynomial, then you don't have shape parameter, right?
yeah.
Yes.
This one, the parameter is 5. Yeah.
The parameter is given 5 in this case.
Okay.
Okay.
Oh, shape factor. Yeah.
Shape factor parameter is the same as risk tolerance.
Okay. Yes, sir.
Okay. So up to here, any question? Is it really clear or you still confused on certain things? Stephen, what do you think?
I'm still following, sir.
Huh?
I think I have no question.
No
Not
question,
yet, I
Darin?
think. Not
Okay.
yet, not yet. Maybe
Okay.
not yet.
Darin, is it clear, really?
Maybe.
What, what does maybe mean? How about you, Eugene?
Yes, sir. Well, I would not say that I already 100% understand, but
Good.
yeah, I think I think I get a gist of what you want to
Okay,
say.
you can
Like what you're trying
grasp
to
the meaning of this lesson. Okay. Okay, so next point, okay, you can use, this is the extension of utility, okay. Another method to compute the decision is what is called CE, okay, later, certain equivalent. Now, for that, to compute the certain equivalent, okay, you will decide first what is called risk premium. So I will share screen to you here. So risk premium is often used in insurance. If you work for insurance company, they will ask you, oh, what is your risk premium? Right? What is risk premium? Risk premium is the amount that an individual like you is willing to give up to avoid possible risky option. Okay? So this is amount of money that you will give to the insurance, okay, to avoid the possible risky option. For example, accident, right? So you pay to the insurance company, okay, so that you will avoid the possible accident, risky option. So risk premium. So what is certain equivalent? Certain equivalent is a number that represents the value. If it's over for certain, it will appear to you as decision maker as being desirable exchange for uncertain or risky option. So in that case, certain equivalent or CE is basically your expected value minus your risk premium. Can you see the chart here? This chart is between the risk on the horizontal axis and the value, okay, the money in the vertical axis. Suppose the expected value is increasing based on the risk, right? Now, certain equivalent is equal to the EV, equivalent the expected value minus the risk premium. Okay. Now, consider for your practice here, consider a winning situation like this. If you join a risky game, okay, it has 20% chance that you will earn 1,000, or it has 80% chance you will lose 125. But if you are not join that game, you are sure that you will earn 75. Now, first you compute the EV, and then you compute the CE, certain equivalent, and your risk premium. Okay. So remember this is the problem, huh? So the EV you can calculate, right? So 20% times 1,000 minus 80% times 125, which is 100. So the CE in this case is the lowest amount of cash you would like to join in the situation. In this case, CE is 75. Remember, certain equivalent meaning that you are certain, okay? If not joined, you are sure to earn 75. That is the CE, right? Then risk premium is easy to compute because now you know EV and you know CE, then you know the risk premium is 25. Okay, what is this risk premium? It's something that you think worth to give up to avoid the possibility of loss. Do you understand the meaning of this? Means if you know someone else EV, okay, then you can ask, oh, what will be the lowest amount of cash, okay, so that you will get the certain things. Then you can actually calculate their risk premium, how much they are willing to give, okay, if you are an insurance company. Is this something nice? Okay. Now, in here, okay, now you want to decide based on certain equivalent, CE. Okay. Now, if you want to decide based on certain equivalent, then you need to assume the utility function, isn't it? So given the expected utility and its utility function, you can determine a certain cash amount which is exactly equivalent. So suppose we use this utility function, U equal to 1 minus expected of minus X over R. Okay, what is this utility function? This is the exponential for risk averse. Right? So then we use algebra here. We get the value of X equal to R ln 1 minus expected utility. So based on this, we can start to decide. Okay. When you want to decide based on certain equivalent, you always choose positive certain equivalent. And you always select the highest CE. Okay. You may have a certain round of error. That's fine. Okay. So, and if you have negative risk premium, that is actually associated with certain risk-seeking behavior. Okay. Let's take an example here. In your previous practice, okay, you compute now the certain equivalent and risk premium. Option A, earlier you get the positive 99, 0.999, and option B, you get the UB is equal to negative 200. Okay. The original problem is whether you will have guarantee of payoff 60,000 or option B is 50% chance you gain 150 or 50% chance you lost 30. Okay. Now, to compute that, okay, then you put into the CE here, the formula of CE for option A and option B. Okay. If you calculate here, you will get 57 for option A, and you will get negative 26 for option B. Okay. So in that case, because CEA is larger than CEB, then you will select option A. So here, we just show in this practice that you can actually, okay, extend the utility theory, okay, not just to calculate based on utility, but also calculate based on certain equivalent. Is it clear or not? Okay, so, but remember, when you use certain equivalent with this formula, okay, you have parameter R here, right? This R here is called risk tolerance, which is constant. So the constant risk tolerance is assumed, right? It means that we change the gamble by adding a fixed additional amount of money to the decision maker payoff, okay, in all possible outcome of the gamble. Then the certain equivalent of that gamble should increase by this same amount. So there is a correlation here that you assume. Okay. Now, in that case, the meaning is if you have CE of A plus B, gamble A and gamble B, okay, that is equal to CEA plus CEB. Okay. If gamble A and gamble B are independent. If they are not independent, so this formula is not correct. Do you get it? So you have certain assumption when you make certain rule. Okay. So as a conclusion here, okay, so this utility theory actually will provide a logical explanation why, okay, certain people buy lottery, which seems irrational. Okay. So now the problem here in utility theory is that it does not include the timing. For example, the lottery drawn today, okay, versus higher lottery drawn by a year from now will be different, right? But this problem can be overcome by computing the present value, like the one that you practiced in the last assignment. So what do you think about utility theory? Do you have any question?
So far, so good, sir.
So far, so good. Okay. So we have finished, okay, the lesson from decision under uncertainty, decision under risk, and decision under utility. So I will stop for a while for 5 minutes, and then we will continue with the group decision. Is that okay?
Yes, sir.
Yeah.
Okay. Right now, I think your time is 10 o'clock. Is that correct?
Yep.
Yeah.
It is.
Okay.
Yes,
So
yes.
let's come back 10:05.
Yes, sir.
Okay. So we come back and continue with our lessons on decision analysis. Okay. So this is the next slide that you can also get from Moodle about group decision making. So this is the topic that we will discuss in group decision making. So first we discuss about the power of in group decision, and then based on aggregation of judgment or aggregation of attribute, aggregation of alternative, and then we discuss about preference orderings, okay, with paradox and arrow impossibility theorem. This is the one that we will discuss in this lesson. Okay. Hey, you are Indonesian, so you're supposed to familiar yourself with Pancasila, correct?
Yes, sir.
Yeah.
Okay. What is sila number 4?
Kerakyatan yang dipimpin oleh hikmat kebijaksanaan dalam bermusyawarah dan perwakilan.
What's the meaning of that?
It's a group decision. It's like voting, musyawarah mufakat.
What's the meaning of musyawarah mufakat in English?
Musyawarah mufakat in English.
Yes. Anyone?
Agree.
Voting? What is the meaning?
Group discussion?
Is that group discussion, Lilian?
I guess musyawarah is group discussion.
Correct. Group discussion is musyawarah. How about mufakat?
Agreement.
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 No. In English, mufakat means consensus. Consensus means everyone should agree with it.
So everyone just accept it.
Yes. Meaning that 100% agree. That's called consensus.
Oh, okay, yeah. Consensus. Okay.
Okay, consensus means everyone agree. Not only one person or two person, but everyone agree. That consensus. Musyawarah mufakat means you do a discussion, group discussion, okay, until everyone agree. So in this lesson, this is the one that we will discuss about it, okay? Of course, we discuss more mathematics of that, but you can see. Now, suppose you have a problem like this, okay? In group decision, right? Usually you have voting, correct? So those who lost in the vote must comply, even if they don't like the decision. Is that correct or not?
Yes.
Yeah, that's what is democracy is about, right? So,
correct.
And the group decision usually binding for all the members in the group. Now, my question to you, what if those who lost does not want to comply? Okay.
Then do they have a better solution?
No, say you make a discussion, okay, and you make voting here. So say 10 of you, suppose you are 10. So 6 of you vote for A, 4 of you vote for B. Now the one who lost, the 4 of them do not want to comply. They still want to do B rather than A.
Okay.
So how does the group and the leader will do about it? How?
They force them to comply.
How to
force them to comply. Yes.
The question is, how do you force them to comply?
Wait, if you force them to comply, I mean, you can only force them to say yes to the decision, but not to do the decision. I mean, like, you cannot keep an eye on them 24/7, right? So it's also useless though.
Yes.
Oh, wait. So if you force them, the vote was meaningless. Yeah. Then how?
Say
If there is no way to
example, okay, in election for your leader, okay, say
like in Myanmar. Right?
presidential election, okay? 60%
Yeah.
select President A, say Jokowi, 40% select who is that? The second one?
Prabowo.
Okay, for example, this is just example. So 40% select Prabowo, but the 40% still want to force themselves that no, we even though we have 40%, we still want Prabowo become president.
In Indonesia, we use guns and law.
So there is force, right?
Yeah.
So there is force in the decision. Okay. So there is no, if you have no way to force them to comply, then your vote is actually meaningless.
Yeah, basically Myanmar. Yeah.
Okay. So voting democracy is not just vote, should have certain power behind it. So remember that in any group decision, okay? So we will not discuss the force in our lesson, but keep that in mind, okay? That there must be certain force to comply, cannot just about vote. When we discuss group decision here, we talk about the voting, okay? But there is certain assumption about it that I need to discuss in the beginning. Okay, there is a force to comply. Okay, that force can be in education. For example, you educate people to understand democracy. That if you lost, you must even comply, even if it is not something that you like. Okay. With that, so this is the example I give example about my own experience. For example, the leader give a vote, okay, that we will finish the project in February, okay, and or we will finish the project in March, okay, and we have an election. 7 people, 7 group vote for February, 3 group vote for March, but the reality, the project leader has no power to force them to finish earlier. So in that case, this voting is actually meaningless. Okay, so this is very simple situation. The point is vote will have force to comply, otherwise it is useless. Now, with that in mind, how do you make group decision, right? So one way to make a group decision is every one of you will have equal weights. You in the group are the judges, okay? Then each judge will have equal weight. And why we need to make a group decision? There is assumption here that individual is unbiased, okay, without tendency to overestimate or underestimate. So when we estimate something, there is certain true value and certain random error. The idea of simple aggregation is the reliability of your estimate increase if the number of group size actually increase. Because the random error can be positive and negative, will be averaged out. So sometimes people say, oh, the more we are in the group, okay, the better our wisdom. That is the simple aggregation method. Okay, so I will give you example here. So you are 3 person, you want to estimate how much is the value of this house. Okay, so A will say, okay, this is about 3 million. B will say this is about 1 million. C will say this is 5 million. Then using simple aggregation, you will say, no, the estimate is actually 3 plus 1 plus 5 divided by the 3 of you, which is 3. So then you will get 3 million. Do you get it or not? So the estimate here, okay, there are certain error in the estimation, but the error is averaged out because you have so many, meaning the standard deviation become very small when you have many judges. Okay, so the problem with simple aggregation is crowd behavior. So people tend to follow the flock. If the first person is actually overestimate, the others will be influenced. It's like the duck here, okay, following the others. So in reality, the reliability of the estimation does not increase so much after 5 individuals. Then another method is proposed. Okay. Oh, if we want to make a group decision, we're supposed to have a weighted average. What is weighted average? Meaning each of you, okay, are expert judges, but the more expert you are, you should get higher weight. Okay. Then we normalize the weight based on the expertise of the judge. So this has been used in many situations. For example, in election in Japan, okay, why from 1940 or 1945, the LDP is one of the political party in Japan, always win. Okay? Because in Japanese electoral system is called apportionate electoral system. It will give more weight to underpopulated rural district. It means farmer, say for example, farmer will get 5 weight. Normal people will get only in the other family, not farmer, will get 1 weight. So LDP is practically farmers' party. That's why they always win, because the weight is not the same. So now, if the judge A is 2 times more expert than judge B, and judge C is 3 times more expert than judge A, then you need to calculate the weight. Okay, A is 2B, C is 3A. Then you set B is equal 1, then A is equal 2, then C is equal 6. The sum of this is 2 plus 1 plus 6 is 9. Then you normalize. That means judge A will have the weight of 22%. Judge B will have the weight of 11%. Judge C will have the weight of 67%. Okay, now based on that estimation, for example, A said it's 3 million, B said it's 1 million, that house. Okay, C said it's 5 million. Then the estimate now based on the weighted value. Instead of 3 million, now become 4.11 million. Until here, is there any question? So this is how you use the group decision to estimate certain things. Are you following? Any question?
Yeah, I'm following.
Yeah,
Ryan.
I want to answer.
Okay, please. Okay.
You said that we need to make the estimation and stuff, knowing that the judge B is more expert, 2 times more expert, or something like that. But in real life, how do you decide that? Like, how do you know?
How do you know that I'm more expert than you, isn't it?
Yeah, I mean, is that something that you can actually decide with number? Because like say our last homework, the last assignment that you just discussed this in the first session, like how do you know the risk that you get 7% is only 50%, and the risk you get 3% is 10% and something like that. I don't think it is something that can also work in real life.
Yes.
It's more like a paper question rather than real life
Okay.
problem.
So your question is, how do I calculate the probability? How I get the weight? Is that what you asked?
Yes, how to find the value.
How to
I think
find the
that's
value?
abstract, yeah.
So the value is decided subjectively. Okay. Remember I told you last time, okay, there are three possibilities to calculate probability. Okay. One is based on your theory. For example, theoretical probability. So if you said it's a coin, you flip a coin, the theoretical probability of that coin is 50-50, correct? If it is a dice, so the probability is 1/6. That is based on theory. Second way is based on data. That means you calculate based on relative frequency. Okay, how much is the frequency of that event divided by the total frequency. So that is probability based on data. Okay, the third is based on Bayes theorem, which is subjective probability, and you keep revising the subjective probability based on event, on situation. Okay, so this subjective probability is based on opinion. Okay, so long time ago, okay, when we said Bayes theorem, everyone disagree at that time, that this 1800s. Okay, so but now it is already accepted as science that people can actually make judgment about probability. Did you get it? So now, based on that judgment, you can revise the probability. Okay, so you have what is called prior probability. This is called the beginning of probability, and then now you get the new probability called likelihood probability based on opinion, a new event. Okay, and then when you multiply the prior probability with the likelihood, you get what is called posterior probability. This means you revise your probability based on opinion or based on the event. That's exactly Bayes theorem. Okay, so it means you can actually make judgment. Oh, based on the previous data, I can get that this is about 6%. If you use based on data, that means you use relative frequency. Okay, so three things you can use. Okay, based on theory, based on data, relative frequency, or based on your subjective opinion. So again, in the weight of the judge here, oh, this one is 2 times more expert and so on. That is subjective value. Okay, I understand your feeling that I want to be objective as possible. But remember, in the beginning of this class, I discussed about art and science, remember? Right?
Yes. Yeah.
Okay, that's why I said, look, not everything is science. Certain things you still need to do art. Okay, so that what make you human. If everything is objective, then you will become machine. The artificial intelligence can overcome you. Did you get it?
Yeah. Okay. Thank you.
Okay, so don't worry to make, don't hesitate to make judgment. Okay, don't hesitate to make estimation. That is what makes you human. Okay?
Okay.
If it's wrong, no problem, because you can always revise what you make mistake. Later on, we discuss Delphi method. You can see this. Okay. Okay. Oh, the next topic is Delphi method. Okay, here it is. Delphi method is an iterative group decision process where you, as the panel of experts, will give certain weight or certain value in your area of expertise. Okay, so the technique is called feedback system. Okay, each person will have opportunity to reevaluate their decision. Okay, after a certain feedback, okay, on the aggregated value. Okay, and actually, in the real Delphi method, the judge does not know the estimation of each other judges. Okay, so that you will not follow the bias, so that you will not follow the others. But in our practice today, okay, you will still listen to others judge. Okay, so and we will see the result, okay, whether it's actually confirmed or not. Okay, let's practice Delphi method. Let me get certain pen here. Okay. I will show you this book. Can you see it? So,
Yeah.
okay. So I will ask you, how much is this book cost? Estimate. Each of you. Okay. Can you estimate? So this is a very thick book. You don't know the value, right? So, but you can give me the estimate. Okay. How much it costs?
2 million? 2
Okay,
million?
one by one, each of you, okay? In the first round, okay, so each of you will give me, we have a chart here, right? So send me your judgment on the cost of this book in your chart. Can you? Now, how much is this? 700K, in rupiah, okay. No, okay, make it in rupiah all, okay. So one said 700K, the other one, okay, I will make Excel here. I will open Excel. So one of you said 700. Second, Abel said 2,000. Okay. And then the next one said, Michelle said 1,500. And the other two. Lillian said 350. Okay. And anyone else? Darren, what do you think? Darren said 1,000. Okay, so I will share my screen to you. Can you see this? So now I take the average. Okay, so I take the average. width is, and I take the standard deviation here. Standard deviation of the sample. So this is the average and this is STD. Okay. So the average is 1,110. This is your judgment. Okay. Now I give you feedback. Okay. The average is 1,110. Now for the second round, tell me, okay, this is first round. Okay. In the second round, tell me, what do you think? Hey, I give you feedback that the average is 1,000 or 1.1 million here. So now give me your second estimate. Can you type your second estimate in your chat? Where is your chat? Oh, I need to. Okay, can you type your second estimate? Michelle said 1,250. 1,250. Continue. Come on. Lillian says 600. Abel says 1.8. $600, $850. One more. Darren said 3,000. Darren, oh, Darren still continues still 3,000, still the same. Oh, Darren, earlier you were 3,000, right?
No.
Okay, I need to put the. I will just on the estimate. Okay. Who said 700 first in the beginning? I will keep the name. Who estimate the 700 in the beginning? Hello.
Eugene, sir.
Eugene. Okay, so Eugene said 700. After 700, Eugene, what is your estimate after that?
850.
850. Okay. Now, who said 2 million here? In the beginning?
I did.
Abel.
Yes.
Okay, Abel said 2 million. How about in the second round? How much is your estimate?
1,800.
1,800. Okay. You said in the beginning 1.5, Michelle, right?
Yes.
Okay. How about in the second estimate? How much is your value?
1,250.
1,250. Who said 350 earlier?
Oh, it's me.
Okay, Lillian. Okay. Now after you get the average is 1.1 million. How much is your second estimate?
600.
600. Who said 1 million in the beginning?
Me, sir.
Karin. And what is your second estimate based on that average of 1.1 million?
I say 3,000.
Your estimate is 3,000 now.
Yeah.
Why you estimate very far away from the average? Anyway,
I think. Yeah, I just tried.
you just try. Okay. So because Darwin is a outlier, so the Delphi does not make a good decision in here. The standard estimation getting higher, okay? Because this is outlier, okay? No problem. So then we make a third estimate then. Okay, Eugene, the
Yes.
to you is what $100. It is 1.5 million, the price of this book. So what do you think? What is estimate from you?
I'm trying to measure it without being influenced by the average, and I think the price won't be higher than that. So yeah, I'll stay with 850.
Still, you will keep 850.
Yeah, I don't think it's that expensive.
Okay, okay. Abel,
I guess I'll go to 1,700.
now you change your estimate to 1,700. How about Michelle?
I think I'm back to 1,500.
You still back to 1,600. How about Lillian?
800.
You change to 800. How about Darin?
2,000.
2,000. Okay. Now you see the standard deviation reduced. Okay, we can continue again the fourth round and so on. Okay, the point is this: by having Delphi method is a kind of feedback system. You see, you ask everybody to estimate certain things. Okay, and eventually, after certain round, okay, you can have a fifth round, sixth round, and so on. After certain round, the average will converge and standard deviation becoming lower and lower. Can you get it or not? So the point of Delphi method is the convergence based on feedback system. Okay. So each of you will give your opinion, right? And then I compute the average and give you feedback on the average and the standard deviation. Actually, I should not let you know the opinion of each of you. I only give you the average as a feedback. Okay, and then I will ask you to reconsider back your opinion based on my feedback. Can you see it or not? So this is how you will change your opinion, okay, based on certain feedback system. Eventually, okay, you will, okay, the group decision will convert to certain value and the standard deviation will gradually reduce and reduce. So up to here, any question, any comment? Do you know what is Delphi method? How do you do it? Is it practical method or not?
Wait. Before answering that, I want to know. So, what is the price of that book?
The price of that book, you check Amazon.
Well,
Okay, let's
no, because like I have a thing like this. If say it turns out that the price of the book is only like 500,000 rupiah.
Okay.
But because we don't know the value and we don't have any like what does it say, pedoman to measure
Yes,
it.
you don't let
We just stating
estimate.
our opinion,
Yes.
and when we saw other give a higher value, then we will doubt ourselves and we start to go higher and higher. And the one that gives a very high value will start doubt himself and
Yes.
lower it. But it can mislead sometimes.
Correct.
It leads you to stray away from the correct price.
Correct.
I don't think this is practical though.
Correct. So any group decision, okay, can go away from the goal, right? Can go away from the actual correct value. But Delphi method will give you precision, not so efficient, not effective. You understand? Delphi method is efficient, not effective. So I will show you the whiteboard here. So say this is your goal. Okay. Delphi method can give you this place, which is far away from the goal, right? So you will think the goal is in here. Can you see it? Even though the actual goal is in this place, okay, Delphi method will give you precision around this value. So you are right, it's not effective, but efficient. It will not go here far, far away, okay? It will eventually keep a certain conversion to a certain value. But look at it this way. Even that in reality, say you estimate certain price of a house, you estimate certain price of an art. Isn't that actually the same as Delphi method? The real value, you don't know. You never know, right? But because people keep saying this is the one, okay, and you get the feedback based on the news, then you actually say, okay, the price of this stock, the price of that house, the price of this piece of art is certain value. Is that correct? Is that the real value? We never know. Okay, but that is how people make decisions, isn't it? So it gives you precision, but you never know the true value. You only believe the precision gives you the true value. Okay, so Eugene, you are correct in this case. Any other comment or question? Any group decision is like that, okay? You don't know the true value. So let's continue then. Another method now, okay? Instead of aggregating the value, you aggregate the attribute. Okay. So now in this case, each individual will estimate the probability of its criterion. And then you take the simple average individual probability on its attribute. Okay. So I give you an example. So in this example, we multiply, say you have two factors, A and B. Okay. Now, if we multiply the just probability and then we take the average, you will get 24%. But if you first average the individual probability, then you multiply, you will get 22%. Okay. Say, just A, okay, the probability of factor A is 20%, the probability of factor B is 60%. Judge B said, oh, factor A is 40%, factor B is 90%. Then you multiply this probability. Okay, and then you take average between judge A and judge B with this 24% here. Okay, so if you multiply factor A, if you take average of 0.2 and 0.4, you will get 0.3. Right? If you take average of 0.6 and 0.9, you get 0.75. If you multiply the two of them, you get 22.5%. So be careful, okay? When you multiply first, okay, and then you take average, it's not the same as you average first, then you multiply. You got it or not? So averaging and then you multiply, and then you multiply first, then you take average. They are not the same result. Okay. Now, this is the core of group decision. Okay. What? It based on ranking. Say, suppose you have judge A or judge X, Y, Z. We'll decide their preference on 3 alternative projects. Say, name it A, B, C. Judge X say that C is more preferable than A, and A is more preferable than B. Judge Y will say, no, B is better than C, C is better than A. Judge Z will say, no, A is better than B, B is better than C. Now, based on these 3 judges, based on the preference of ordering, my question is, which project should you select, A, B, or C? What is your opinion? You have 3 judges, okay? X, Y, and Z. And you have 3 projects, A, B, C. You should select now what is the group decision. These are the preference ordering. Any opinion?
I don't think any of them stands out.
Yes. So, you know why? This is what is called Condorcet paradox. Okay. So, if you compare 2 alternatives and then you vote, okay, in this case, A is larger than B, isn't it? Because A get 2 votes, B only get 1 vote. Now, if you compare B compared to the C, okay, B get 2 votes, C only get 1 vote. In that case, you will say, okay, A is better than B, B is better than C. But if you compare C compared to A, B get 2 votes, C get 1 vote. With this contradiction, right? Because it violates the transitivity. What is transitivity? If A is bigger than B and B is bigger than C, if transitive, then A must be bigger than C. But in this case, it's not. So it's a paradox. Okay? When you judge based on the preference, okay, there is possibility of paradox. In that case, you cannot decide. Now, if the alternatives are not compared simultaneously, but in sequence, the order of comparison have direct effect. Okay, so if the group will compare A and B first, and then you eliminate the inferior alternative, okay, and compare the superior alternative to the next alternative, A will win. Right? So say A compared to C, C will be chosen. So if the group will compare B to C first, B will win. Okay? If you choose B compared to C first, okay, B will win. And then you compare to A win, then A will be chosen. So remember, in preferential ordering like this, the sequence matter. Okay? So if the group will compare A to C first, then C will win. Right? And then if C compared to B, B will be chosen. So in the summary, if you have this problem, okay, in the beginning, if you choose A and B, and then the choice will be C. If you in the beginning you compare B and C, the choice will be A. So the group choice by majority rule is actually arbitrary. Okay, so this is actually irrational behavior in group decision. Okay, this is which called arrow paradox. So group decision can lead to inconsistency in decision process. Okay, Arrow is the name of person who win a Nobel Prize for noticing this problem. Okay, so why he can win a Nobel Prize? Because actually, okay, you can cheat based on information. In a sequential alternative, a clever group member could cheat by being dishonest about his own preference. So simply by delaying your decision and listen first, okay, this clever group can win. This is an example. Okay, so say the clever group in here is Z. Okay, suppose, okay, Z preference order is A larger than B larger than C, right? Okay, suppose A compared to B first. Okay, now Z knows, look at that table below here. Z knows that if he uses his own preference, okay, C will be chosen. Of course, he wants A to win, right? In this case. So Z will lie about his order of preference. He will say, no, he will say, no, actually B is larger than A, larger than C. Okay. By lying about his own preference, because he knows the other preference already, okay, this will make B win, not A, in the first round. And then in this case, B will defeat C in the second round, right? So simply by delaying, okay, when you listen first to other judgment, and then you delay your decision, your preference order, you will win. Something that you want will win. Can you get it or not? Give me comment, give me a question if you don't get it. Anyone? Abel, what do you think?
I don't really get it that cleanly, but
Which part you don't get?
I mean,
You compare two, okay, each of you as a judge, you will give a preferential order. And you know, you will select among two. Okay, you will select among two in the preferential ordering. In this case, in the first round, if you look at this, okay, if Z is telling that, oh, my order is actually B larger than A larger than C. So in the first round, you see that B is actually larger than A.
Okay, because two
Because
people
B
say,
get twofold, right? In the
yeah,
second round, you check B compared to C, okay? Again, B is winning because B get twofold again,
okay,
okay? By solving the paradox. So Z in here, actual preference of Z is A larger than B larger than C. But meaning that Z want A to win, correct?
Z1, yes, yes. Okay.
Right? Z want A to win, okay? By lying his own preference order, okay?
Okay,
Z can make A to win.
okay,
So in the group decision, okay, when you use preferential order, okay, so actually there is possibility that if you delay your decision and you listen first, okay, the one that you want to win can win. So Arrow is the name of person. Arrow asks whether there is a satisfactory method to determine a group preference, okay, when the preference of individual member are expressed in ordering like before, like that previous example. Okay, and he lists down 4 conditions that a satisfactory procedure should meet. Only for order preference, not include the this condition is for only for the order of preference, not include the value of the preference. Okay, so these are the 4 conditions of Arrow. Number 1, the method should produce transitive group of preference of order. Transitive means if A is larger than B and B is larger than C, then A must be larger than C. Okay. Second, if every member's preference prefer one option over the other, so must the group. So there must not have certain paradox here. Third, okay, the group choice between 2 alternatives, A and B, okay, depends only on the preference of the members between this alternative and not on the preference of any other option. Meaning the individual cannot cheat. Okay. Number 4 is no individual can impose his or her preference to the group. So there is no dictator. Now, Arrow win a Nobel Prize by proving, okay, of what is called Arrow impossibility theorem. He proved mathematically that no aggregate procedure can guarantee to satisfy that all 4 conditions above. Okay, so this result is significant, but actually also depressing. What? It is impossible to derive a truly democratic system to resolve difference of opinion. Okay, so yes, democracy can work, but to resolve difference of opinion is not always possible. In fact, he proved it impossible. Up to here, any question about this? Okay, so for your practical way, okay, if you want to make a group decision, okay, the way to a simple way is basically based on voting. Voting of all alternative, okay, and then you select which among your alternative that is at least acceptable. Then you find the alternative that received the most vote. Okay. In this way of approval rating, okay, you practically ignore the information about individual preference. But by doing so, you actually also avoid the paradoxical result. Okay. Simple vote among the alternative is a most practical way to select your alternative. So any question up to here? Look at the significance of a group decision. Okay. In marketing, for example, or in any future application, okay, basically what makes you human is you will be the judge. Okay? The artificial intelligence, the robot can do work for you, but what makes you human is to evaluate, to give rating. Okay? So say, for example, the robot will make a piece of art or a piece of music, right? Which at this point you will think this is a creative work. Okay? Then what is the human role in that case? The human role is to judge, to give approval rating. Oh, I don't like this music. I don't like this art. Do you get it or not? So by making judgment over something, it is what makes you human. Okay, that is the main result, main point of group decision making here. So up to here, any question, any comments? So the lesson on decision analysis is finished. Okay, that means from the beginning until this lesson, you will have a quiz next week. So please practice, please read the slide again, okay? Then you will have a quiz next week in Moodle.
Okay.
So the quiz is the same time with the class?
The quiz is within the class, yes. So it's only 15 minutes maximum, maybe 5 minutes only.
Wow. Okay.
It's multiple choice anyway, right?
Yeah, I'm dizzy. Okay, I'm dizzy right now. Okay.
Okay, so you need to read and practice to be able to answer those questions. Okay? So, any question, any comment about what you learned so far?
Looking forward to the next one.
Okay, next one. Okay, the next one is game theory. You can download this slide in Moodle, right? So this is an introduction to game theory. So in this lesson, we will define game theory, the objective, the assumption, and the component of game theory. Okay, so this is part of decision analysis, which is called decision under conflict. Okay, previously we have discussed about decision under certainty, uncertainty, risk, and utility, and group decision making, right? So right now is the last part, okay, which is actually decision under conflict. So in this case, you have two groups, okay, of individual or a group that you make decision, and now you want to find the equilibrium point. So game theory studies how smart, how ruthless people should act and interact in strategic setting. Okay. Game theory is a systematic study of strategic interaction among rational individuals who has conflicting or cooperating interests. Okay, so remember, when we said game theory, you think about strategic decision, strategic interaction. The assumption here is everybody is rational. Okay, so in game theory, you are concerned with the action of decision maker who are conscious about their own action, that it will affect other decision maker. Okay, so the strategic interaction means that the individual know that their action will have an effect to the outcome of others, and they will act accordingly. So there are two ways. One is called cooperative game, okay, and the other one is called competitive game. Now, in cooperative game, okay, cooperative game is a game in which the players can make a binding commitment, okay, as opposed to non-cooperative games, which they cannot. In cooperative game, you have two possibilities. Okay, cooperative game with conflict or without conflict. Cooperative game without conflicts, okay, the member will choose, okay, what is the best way to coordinate each other. In cooperative game with conflict, okay, in this case, you will have bargaining over the price. So bargaining is actually a game. Now, when we say competitive game, okay, this is also called strategic game. So when we said strategic game is basically competitive, non-cooperative. There is no binding agreement here. Now, again, you have two possibilities, with conflict or without conflict. Later on, we will discuss about what is called prisoner dilemma game. This is an example of non-cooperative game with conflict. Okay. Another possibility is non-cooperative game without conflict. So the example is you have two companies to set a product, okay, standard without communication. So I give you an example. In Microsoft, for example, okay, creating what is called Internet Explorer, right? And then Google creating similar, which called Google Chrome, right? So they are competing each other. They are non-cooperative, okay? But at the same time, okay, they make game, okay, non-cooperative, but they do it a certain standard. So they set a standard together, okay, so that between Internet Explorer and Google Chrome, Apple creating Safari, right? So the three of them creating certain standard so that all browser will have certain rule. For example, now all browser will accept JavaScript, right? As a programming language that can use. All browser will accept HTML, for example. Did you get this example or not? So even if you make a conflict, or even if you if you do a competitive with other company, okay, you can still make cooperation within that competition, which is by setting a standard together. Now, in strategic game, the focus of the game theory is actually on strategic game. In strategic game, you have two or more players. Okay, you have certain choice of action or certain behavior, and then each choice will have one or more outcomes. Okay, now the final outcomes depend on the strategy chosen by all players, not only you, but you and your opponent. And your decision will have impact on each other. So there is certain interdependency. So look, when I said games here, okay, it does not include games of pure chance, for example, lottery or slot machine. Okay. It does not include games without strategic interaction, for example, solitaire game. Okay. So the goal of game theory is to organize our knowledge to increase our understanding about outside world. In game theory, you will have a predictive power. Now, to achieve this goal, okay, game theories postulate certain rules to which the individual can act or behave. What is their objective? And how the rule of the game, they try to, within the rule of the game, they can try to achieve that objective so that they can predict, okay, what they can do in a given situation. So the assumption of game theory is there is no mercy, there is no compassion, there is only self-interest. Okay? In game theory, you assume that people only care about themselves. And everyone knows and accepted this. Okay? So in game theory, only have self-interest. There is no mercy, there is no compassion. So what is the implication of self-interest? For example, oh, the employer will never give you a raise because it is a nice thing to do. Okay. Actually, you will get raise in your salary only if you can convince your employer that it actually serves their interest to give you more money. When you want to bargain, okay, when you want to bargain to increase your salary, you need to convince your boss that it is within his self-interest to raise your salary. Do you got it or not? using game theory, you will think in terms of self-interest of others rather than yourself. Okay, so beware, however, if you end up enjoying this lesson, because it is not because I teach it in the purpose to make you happy. Okay, I teach it to maximize my own payoff. Okay, when I teach you this, it's because of my own welfare, not for your welfare. Now, the assumption in game theory, the next assumption in game theory, aside from self-interest, is rational. So each individual in game theory will do rational decision. Each individual know the strategy available to each other individual, and our knowledge is complete. This is the assumption, okay? Our knowledge is complete. So we know the consistent preference of all possible outcomes. And then from here, we can determine the best strategy. And we can implement this strategy. That is the assumption here. So it is not enough that I know that my action as well as your action will affect the outcome. But I must also know that you know this fact. That is the meaning of rational decision here. Okay? So game theory is used also in military. Okay? So this is an example. So you have two nations. Let's call this row nation and column nation. So now you have three decisions. Okay? Row nation will have three alternatives, R1, R2, R3. And then column nation will have three alternatives, C1, C2, C3. Then you will have this outcome table, payoff table. This payoff table is for row nation. If row nation do decision on R1 and column nation do decision in C1, the result is fail for row nation. But if row nation do R1 and column nation decided to use C2, then it is success for row nation. Okay? And so on. Now the question in here is, which strategy is the best for row nation? And what strategy is the best for column nation? This is what game theory is about. Given this table, you will decide for each player, in this case row and column, what is the best decision.
Oh, is this like Bonnie and Clyde case? You know, Bonnie and Clyde.
Okay. So game theory is something like this, okay? So given this table, okay, give me the best decision for each player. In this case, you have two players, right? So is it clear or not? So remember, each nation does not know what other nation strategy will be selected. So this information is not known, meaning that what they will choose, we don't know, okay? But we know all possible strategies, all alternative of opponent, we know. And we also know the payoff, okay, of the opponent. This is the assumption here. So practically, you know the complete plan. Okay, and we also assume, not only we know, we also assume that the opponent knows also all the possible strategies and its payoff from our point of view. Did you get it? So the table are the same from you and your opponent. This is the basic assumption here, okay? Because otherwise we cannot play games. The rules are the same, right? So now the question is why we learn game theory. By learning game theory, you will learn that even when everyone actually act ruthlessly, extremely competitive, okay, the logic of game theory dictates that selfish people actually cooperate and they treat each other with loyalty and respect. You understand? So you will also learn based on your move what you think of other people might do. Even if your move is based on what your opponent might do, and their move is based on what they think you are going to do, then your move will in fact be somewhat based on what you think your opponent think what you will do. Meaning you can always think about others, okay, based on your selfish ambition. Eventually, because you think about what the others will do, okay, based on their selfish ambition also, then you can actually treat each other with loyalty and respect. Okay. This is amazing, right? Because in Indonesia especially, you probably run, oh, we need to be altruist. We need to help each other and so on. But in Western nation, they start to think in terms of game theory. They don't like to cooperate, but they need to cooperate because they are selfish. And game theory is the way to explain this. This is amazing, right? So now there are 4 game components. The basic part. Of course, you have set of players. In this case, you have 2 players. You have action, which is the alternative, right? And you have payoff for each action, for each alternative, for each player. And then you have information about it. Okay? So the players are individual who make decision. They are rational players, so their goal is to maximize their utility. Okay? So they want to maximize their payoff. That is what is called selfish. They want to maximize their own payoff. And each player is assumed that other player is also trying to maximize their payoff. Now, how about if I'm individual? I don't have any other opponent. Then the nature can be a pseudo player. So that means this is an example that a single player play against nature. Okay, so say you are an oil company. Okay, this is the payoff in $1 million. Okay, the decision is either you drill or you sell your equipment. Okay, you drill in this project or you sell your equipment. If you drill and you have no oil, you will lose $7 million. If you drill and you have oil, you will earn $10 million. If you sell your equipment and it has no oil, you will earn $1 million. But if you sell the equipment and it has oil, you lose opportunity of $5 million. You got it? So this is exactly the same as decision under uncertainty or under risk or under utility, isn't it? So the question is, which strategy is the best? Now, in game theory, you can have more than 2 players, okay? But in our study here, of course, we only have two-person games. Now, action, when we said action is the alternative. Okay. Sometimes the game theory will have certain action and actually have set of action, and you can have combination of action. Meaning that you can create the decision tree based on this. Okay. So this is in general, but we will not go further into this. When we say strategy, what is strategy? Strategy is the plan of action. Okay, it's a complete set of instruction, and we assume that the strategy is a plan that is complete. Okay, that you cannot upset by the opponent action or nature. Okay, complete means you know all alternatives. Okay, what's the difference between action and strategy? Action is actually strategy in a simple game. Okay, action is observable, but strategy is not observable. Action is physical, and strategy is only mental. Okay, now player strategy is a rule that tell him which action to choose in each instant of the game. So in our game theory, we will say action equal strategy. Now the payoff. The payoff is basically the consequence of its action. Okay, whether it is in material reward like money, or it is in utility like pleasure, dissatisfaction, and so on. Okay, so be careful here. There are two meanings of payoff here. One is the utility player that they will receive after, okay, all the player or nature have picked up their strategy. Second is the expected utility that they will receive as a function of strategy chosen by him or the other player. Okay. Now, when we say outcomes of the game is the set of interesting element of the modeler that you will pick based on the payoff, based on the action. Okay. And finally, you will see later what is called equilibrium. Equilibrium is a strategic combination. It's the best strategy for each of the player in the game. So remember, equilibrium is the best strategy for each player in the game. So our goal is to find the equilibrium. Okay. Now, equilibrium is not always exists. In game theory, equilibrium is not always exists, and it is also not always unique. In one game can have no equilibrium, can have more than one equilibrium. Okay. So in the next meeting, we'll discuss first about zero-sum game. After that, we'll discuss about competitive game, where the game is not, the payoff is either positive or negative. Okay. When we said zero-sum game, meaning the payoff equal to 0. Your winning is my loss. Okay. My winning is your loss. That is zero-sum game. Okay. So until here, I think the time is up. Is there any question? Please read this slide. Okay. And the next slide, the next two slides as well. Hello, are you still there?
Yes, we are.
Yes.
Is there any question?
I guess not.
Okay, so next meeting, okay, we discuss game theory, you read before the class, and then you also read from the beginning until the decision under utility and group decision. That will be your material for the quiz next meeting. Okay?
Okay, sir.
Okay.
Okay.
So see you next week then.
See you. Thank you.
So yeah,
Thank
thank
you.
you, sir.
Yeah,
Thank you.
See you.
Thank you.
Yes, sir.